So we just finished doing reciprocal functions in 30S Pre-Cal, so this is kind of a refresher lesson for you. So sometimes they give you either a piecewise function or some function, or you have to graph a function, and that then you have to sketch 1 over f of x. Of course, f of x can't be 0 because you can't divide by 0. So to sketch 1 over f of x, we need to determine the reciprocal of all the y values. Why is it the y values? Because f of x is just a fancy name for y. Note, we learned the other day that the inverse function is something else. It is not the reciprocal function, so do not get them mixed up. Now in this course, we're going to be talking about both, so you have to have it very clear in your head they're not the same thing. So how do we do this? The original function's x-intercepts become vertical asymptotes. You need to draw those. Any y value that is 1 or -1 will stay the same. Why is that? Because if I reciprocate 1, it's still 1. If I reciprocate -1, it's still -1. These are invariant points. Where f of x is positive, 1 over f of x is positive. They don't switch sign. You just reciprocate it. Where f of x is negative, 1 over f of x is negative. Large values from f of x, when you reciprocate this, large, if you think about 1,000,000 and you reciprocate it, you get 1 over 1,000,000, which becomes very small. Small y values, again, if you think of 1,000,000,000, but it's 1 over 1,000,000,000, if I reciprocate that, that would become 1,000,000,000. So they would become very large. So that's the concept that you're kind of thinking about when you're transforming these points. Points that remain unchanged through a transformation, of course, are called invariant points. Okay, so given the following f of x, sketch the reciprocal. What's the domain and range? Okay, so the way every single time you should start this is any x-intercepts become a vertical asymptote. I'm going to change color here since this is blue already. So vertical asymptote at x equals -1. Then the next thing I do is I plot the invariant points. So that would be a height of +1 and a height of -1. Then you use the concept small becomes big. So between 1 and 0, those are small numbers. So when you reciprocate that, it goes big. What's the biggest number you can get to? Well, it's not a number, but it's a concept of infinity. Same with very large numbers. They become very small. What's the smallest we can get to? Well, we can't get to 0 without it being 0. So we approach it. So we end up having a horizontal asymptote on the far left. Again, between -1 and 0, we have very small numbers. So when I reciprocate that, I get very big negative numbers. So what's the biggest number concept you can get? Negative infinity. On the right of that invariant point, I have big numbers. It's getting bigger and bigger. So when I reciprocate, it gets smaller and smaller. So the smallest I can get is 0, but we're not actually going to get to 0. So we have another horizontal asymptote on the right far side. Do not draw the horizontal asymptote through the whole thing, because you'll notice in grade 12, just because far lefts and far rights have horizontal asymptotes, it doesn't mean it's an asymptote throughout the whole thing. In this case it is, but it's not always going to be that case. So what is my domain and range? My domain is negative infinity to -1, round bracket, -1 to infinity. My range, negative infinity to 0, 0 to infinity. Okay. Next example. Given the following function of f of x, sketch 1 over f of x, what's the domain and range? So this is a little bit different than what you're used to, but you use the same concepts. You got to find any asymptotes. Again, asymptotes occur where there's x-intercepts. So we have 2 in this case, an asymptote here and an asymptote here. The next step is to do the invariant points. The invariant points when you have a height of 1 or negative 1. So I have one here and I have one here. Okay? So what's going to happen at the top where it curves up to 6? We'll reciprocate it. You get 1/6. A height of 4 would be 1/4. So it's up to you how you want to do this, but essentially it's going to go as low as 1/6 there. So, and it's going to approach this this height of 1. So you can see it's pretty minimal until it gets to there. It looks like I dropped down, but I'm not. And then in between the 1 and the 0, it's little positive. So when you reciprocate that, you get really big positives. Same with on this side. It's kind of getting back far up and then coming totally up. Notice there is no horizontal asymptote on this one. There's just 2 vertical ones. So this one's an interesting one to do domain and range. So I'll give you a second to think about that. So domain, this time it's going to be round brackets on -6 to 6. And my range, what's the lowest that I have here? Remember, the lowest was the 1/6, and it actually equals 1/6, so I'm going to have a square bracket around 1/6 going to infinity. Next one, again, use the same technique each time. X-intercepts are asymptotes, vertical asymptotes. So draw them in. Height of 1, height of -1, invariant points. There you go. So does everybody see where my invariant points are? So on the right far side, looks like a typical reciprocal graph. Smaller flips to bigger, bigger flips to smaller. So then we have another horizontal asymptote because it approaches 0 without actually being 0. On the far left, smaller becomes bigger, bigger becomes smaller. Okay, now in the middle, it's interesting. Do you see that it only goes as far low as -2? So we're going to reciprocate -2, which is -1/2. So that's how high up it gets. So do you see I'm curving it around, smaller becomes bigger negatives, and it's going to curl up, smaller becomes bigger negatives, like that. So this is interesting how the domain and range will be now. I'll give you a second to look at that and figure out what the domain and range is. So -infinity to 3, union 3 to 3. Oops, I didn't put the negative in there. -3, sorry, to 3, and then 3 to infinity. Okay, range, it goes as far low as -infinity, goes as far up to -1/2. It includes the -1/2. Then we have a big jump, and we start back up again at 0, but it's not actually at 0, and going to infinity. So those are good ones. Next one, again, same technique over and over and over again. X-intercept, vertical asymptote. Invariant point, invariant point. Smaller becomes bigger, bigger becomes smaller, so I'm going to have another horizontal asymptote coming off that. Smaller becomes bigger, bigger becomes smaller. I have another asymptote coming off the left side as well. So I'll give you a second to find your domain and range. So -infinity to -1, union -1 to infinity, and my range is 0 to infinity. All right, this time I am given the reciprocal function, and you have to figure out what the original function is. That's kind of cool. So you kind of work backwards. Remember, the first thing we did was wherever it crosses the x-axis, we have vertical asymptotes. So put those x-intercepts back in where those vertical asymptotes are. Then, of course, wherever it's 1, it's still going to stay as 1. So here is 1. Here is 1. Okay. And so what's going on there in the middle, though? Well, it looks like the height of this parabola-shaped middle section is a height of -3. So that's the reciprocated amount. So that means I should go reciprocate it back. So what would -3 become? It would become -1/3. So say about there. And then, of course, if you want, you can do the -1/4 and so on. But you can see this is it a parabola going that way, or is it an actual absolute value? It looks more like an absolute value the way the shape's going. It's not very curvy, it's more straight. So there we go. There we go. Would you have done that? By the way, now that you have the original function, you can go backwards and see if you would get that, right? So again, where it crosses the x-axis, that's where my vertical asymptotes are. -1/3 would become -3, smaller would become bigger negatives. You see, it all works out here.